Bueno, a lo mejor. Uf, hay que apagar uno de ellos, ¿no? A lo mejor o no.
A lo mejor sí.
Sorry. Ya. Vamos a comprar un poco. Toma.
Sí, bájalo un poco, sí. Sí, si no yo grito, vamos. Tengo 4 berridos.
No se escucha en casa, pero...
Ah, ya. Eso es verdad. Hola, hola. No demasiado, no. Claro, si puedes apagar... De hecho, apaga el de él. Claro. Hola, hola. Try to speak. Yes, that's good. We cannot hear you. And that's good news. Vale. Bueno, es que esto es España. O sea, son las 7:04. Si empezamos esto, la mitad de la gente se abre de la charla. Esperamos unos minutillos, si os parece, ¿vale? I was saying that this is Spain. This is 7:04. Unbelievable to start now. Vale. This is actually good. Let's start with some questions.
Go ahead. No, but I was talking in German.
Oh, German.
But
Anyway, use the microphone.
We can translate it later. No, I have no question yet.
Ah. Bueno, de todas maneras, antes de empezar, I'm going to make a little bit of Spanish. No, actually, no. Anyone has a problem if I speak in English also? No? Okay. So, let me ask you one question. Who knows Markus Winand?
I try to. Hey, I'm online.
Yeah, maybe it's okay now, or...
Seems like.
Yeah, we can deal with this. We can deal with this. All right. So, for those of you who came in time, and this being Spain, of course, it's quite significant to have Markus today here. I'll leave this for the presentation later. Anyway, have you seen his book? In Japanese, it's available in French, and it's available in Spanish. I personally contributed to that last part by delaying it.
And by improving it.
Okay, hopefully that part too. But it took me a while to review the book. So, if you want to learn about indexing, if you want to know more about SQL performance, I definitely recommend you to buy this book. Yep. It's available online.
Buy this book.
From many stores online in many languages, as I said. I've read this book, obviously. And I could say you will learn a lot. Even though you think you're a SQL expert, an indexing expert, you will learn a lot anyway. And we have 3 books here. We're going to give them away at the end of Markus' talk. So, first of all, don't leave, because you can get a book and you can get some pizzas for free. Really good deal. And start thinking of good questions to ask Markus. If you're able to leave them without an answer, you'll get a book.
Okay.
Yeah, that's tough. Just give it a try. I'll let him answer the question.
It's for all SQL databases, but it does also cover Postgres. But I must admit the primary database used there is actually Oracle. Postgres users like it.
Yeah, absolutely. Actually, when you read the book and you see the explained output of non-Postgres databases, you're just like, what is that?
I mean, besides the book, there's also this website, usetheindexlook.com. Do you know that? Yeah.
Use the index look.
Yes. It's the same. It's the same content. You can go there on the website and read the book for free there. Also the Spanish version. And there you can just look to see if you like it. It's totally free. Just take your mobile, look there.
I have to admit that I'm being addicted to modern SQL.
Ah,
I'm being addicted to
okay.
every day I discover something.
That's great. So Modern SQL is my other website I run, which is now being grown, and it will eventually become a book as well, at some distant point in time.
Not so distant.
But you can subscribe to the newsletter, and you can go there and you can read everything for free. So all my content is for free. But at the end of the day, I still have to pay bills, so you can also buy books.
All right. By the way, we expect hopefully more people coming. There's space here in the front rows. Markus is not going to bite anyone. And real Markus fans can go on the first row. Like Jorge. So feel free to come over to the first row. That's it. Awesome. All right. So.
And there is stuff to take away. There are stickers and coasters. Show the coasters.
Yeah. Coasters look like this. Right? Let me ask you a question first.
Yes.
How many... Sorry, maybe I'm spoiling you something. Okay. So how many of you do use, you're building a web app or a desktop app, doesn't matter, right? You're showing a listing of results of a given query, and you want to offer users some pagination, right? And what you do, limit offset, right? It's great for that. How many of you do use limit offset for this kind of job? All right, you all need this. Don't do offset. It's evil. Yeah? Take it. Take it. Yeah. Go to Markus' website. He will explain why. Maybe also some hints today. Grab some coasters. They are free. These ones are free. They are there in that table at the entrance. There's some more here. Right?
Yep.
So, join the no offset movement. We've done this before. All of our customers, when we do a report to them, we include a copy of this logo. You just make sure they don't screw them up. They just shoot them on their feet, right? What else?
There are also stickers.
There's also stickers.
So no offset stickers, use the index loop stickers, modern SQL stickers. And of course my business cards.
Okay, and also his business cards. He needs to pay some bills.
Yeah.
He's
To
a
him.
father. To me? I think it's a bit otherwise. Anyway, yeah, whatever. So, are we ready with the streaming? Is streaming live? Are we live already? Yeah. Oh, cool.
Oh my god.
We didn't know that. All right. So, it's still early for Spanish time to start, but I think we're going to start anyway.
As you like it. We can also wait.
No, I like it.
You like it. Okay.
Yes.
You're the boss.
We'll try. So, let me start first. Again, thank you all for coming here. This is a new PostgreSQL España event. It was a significant gap before we restarted PostgreSQL Spain events last month, where I was also speaking here before 1 month ago. Some of you have been here. And today we are very, very pleased to have Markus Winand here. Let me just go a bit in Spanish just to make sure. Also for the records, because it's still Postgres Spain. Como decía, que gracias a todos por venir a este segundo evento de esta nueva época de PostgreSQL España. Como muchos de vosotros sabéis, porque estuvisteis aquí, hicimos una primera charla el mes pasado, donde yo en concreto estuve hablando de configuración para PostgreSQL, y uno de mis compañeros estuvo hablando de algunos pequeños truquitos para Postgres. Nuestro objetivo en esta nueva temporada es organizar siempre una charla principal y una charla pequeña. La pequeña, pues truquitos o consejos breves. Hoy, dado que tenemos una figura mundial, vamos a suprimir esta pequeña charla y dejarle todo el protagonismo a él. Y nada, bueno, comentaros, lo voy a comentar ya casi, si nos importa, en inglés también, para que Markus lo siga, un poco su trayectoria, y ya os dejo, ya no molesto más. So, going back to English, what I was saying is that typically we are organizing these talks a small quick talk at the beginning, just 5-10 minutes with some common tricks for Postgres. We're not doing this today to give you all room for yourself, because topic is quite. Yeah, we ran out of tricks. And la última cosa que quería decir es un agradecimiento enorme a Liferay en primer lugar, que siempre está dispuesto a organizar estos eventos, que siempre nos ayuda con esta fantástica sala. A mí me encanta dar las charlas aquí. Tienen todo el streaming live y luego grabado, que mucha gente que está fuera, hay mucha gente que nos sigue desde Latinoamérica y Hispanoamérica que luego puede ver la charla grabada, y eso se agradece mucho, tener el streaming. Así que y también contribuyen también con la parte de comida y de bebida, así que muchas gracias a Liferay. Un aplauso, por favor. Y también, si quieres, creo que además también en Liferay estáis contratando, ¿no? Si quieres comentar algo al respecto.
Sí, bueno, siempre tenemos los procesos de contratación abiertos, o sea que si alguien cree que este es su sitio y que puede aportar algo a Liferay, que seguro que sí, no dudéis en meteros en la web y ver a cualquier tipo de los puestos que tenemos abiertos, o si no encaja exactamente con alguno, enviarnos el currículum, porque estamos en ello en proceso de contratación. Normalmente sí que lo estamos, o sea que animaos si alguno cree que puede aportarnos valor al futuro de Liferay. Y gracias por estar aquí también.
Gracias. Y también quería agradecer a el otro de los sponsors de este grupo, que es quien organiza todas estas charlas, que es Ongres, que es la empresa para la que trabajo, y que también actualmente está contratando. Entonces, si alguno de vosotros está interesado en ser el próximo Tom Lane, o al menos intentarlo, el próximo experto de BA de Postgres, pues tenemos también abierta una serie de puestos a ese respecto, y donde además enseñamos también mucho a trabajar con PostgreSQL. Así que si queréis hacer una carrera profesional en PostgreSQL, pues hablad conmigo, con cualquiera de mis compañeros, que estamos por aquí unos cuantos, y bueno, en nuestra página web también lo podéis encontrar, ¿no? Así que también gracias, y estamos a vuestra disposición. Así que poco más, os dejo con Markus. Markus, there's few words left to introduce him. World-renowned SQL expert, even though he hates that term, but it's the truth. Author of 1 book and a half, and several websites with tons of SQL information. And he's going to talk today about the really, really cool parts of the newer SQL. SQL is pretty broad, pretty old, and most people are stick with the really old part. So here's what is the future looks like in SQL, how it's going to look in Postgres, and what else can I say? All yours. Thank you very much for being here. Really appreciate it.
So, welcome and thank you for having me. What I'm going to talk about is what I'm interested in lately is the SQL standard. You already mentioned that you like the website modernsql.com. So at some time during my work I realized that there is a standard. It's hardly known, it's barely followed, but there is a standard. Let's have a look what's in there. And I found out that the standard is quite useful, and there are many, many interesting concepts and ideas and features in there which we would all love to have, but for the first, many database vendors are not offering them, and even if they do offering them, hardly any developers knows about them. So this is the gap I want to close with this website Modern SQL, and also with this presentation. And when I started to look at which database is supporting which of these features, there is a matrix coming out, and there are check marks and there are crosses. And if you do that matrix for a while, you will find out that Postgres stands out. It has better support of the SQL standard than some commercial databases. And this is the topic of this talk. I'm presenting you, we will walk through the history of the latest few Postgres releases, and look at features they introduced, standard SQL features, and compare how long other databases have them or don't have them yet. And we will also look into the future, into the near future, like Postgres 11, Who is already using Postgres 11? In production? Yeah. It's not yet released, but there's a beta already available, the second beta already, so check it out, download it, compile it. It's really easy to compile and test it and check it out. You will see features that come new with Postgres 11, and I will also show you, just quickly tease you, some features that may come at later releases. Okay, so let's get started with an excuse. I'm sorry. There was a Postgres conference. Here in Madrid. Yes. 4 years ago. Who has been there? Raise your hand. I have to drop my hand because I was not there. And I'm sorry. That's all I can say. I'm sorry. I missed that opportunity to visit Madrid. It's actually my first visit to Madrid today. I enjoyed it very much so far. Alvaro took great care of me. Got me drunk, but great care. But there's my first suggestion for you. Don't repeat my mistake in missing a Postgres conference. Because there's one Postgres conference in Europe every year. One big one. And this year, it's in Lisbon. And frankly speaking, that's not so far away. You can go there. So think about it. You can already subscribe, I think you can already sign up. Yep. The dates are fixed, the place is fixed, everything is fixed. I'll give you 1-2 minutes to enroll, and then we can start with the presentation. No, seriously, I've been to many Postgres conferences, and from user perspective, I definitely like the European Postgres conference the most. So if you're a Postgres user and you have never been at a Postgres conference, think about that, because it won't be so close any soon, I guess. The year before it was in Warsaw, that year before it was in Tallinn. I mean, that's far away. So think about it. Okay? So that was the opening. Now let's come back to the elephant. How to stay ahead of the competitor is just by getting up early and following the sun. So when the sun rises, we have to start to work. And this is what Postgres has done for the last few years very successfully. So I'll start with the release of Postgres 9.5, just randomly. I could go back for many, many years, but well, okay, that's pretty pointless. So I just do the last few releases and the next few. And there was a feature with Postgres 9.5 introduced. It's called grouping sets. Who knows grouping sets? Oh, come on. Who knows group by? Okay, that's a basis. I can work with that. So every new feature introduced basically fixes a problem. And I would first like to show you the problem it fixes so you can understand the solution. And the problem with the group by clause is that it can only do one grouping at a time. So that means if you want to do a report that gives you some monthly revenue figures, like one row for each month, therefore you have a group by which goes down to the month, okay? But at the same time you would like to have the super total on the yearly revenue, for example. How can you do that with SQL? It's actually easy. Because SQL from the beginning was designed as using composable components, like Lego bricks. You can combine them. So it's no problem. You just have a second query which does the group by only by year. So you can either run two queries, but of course you can also combine them, like Lego. And you put a union all in between. You have to make sure you have the same number of columns and the same types of columns. And then you have basically one query that gives you all the results in one go. Hey, SQL is composable. That's one of the powerful things of SQL. Except that it's a little bit ugly, and nobody ever did it that way. And of course it's not slow, it's not fast. So this is the problem that was fixed. If you want to do more than one group by in one operation, you can use grouping sets. And it looks like an extension to the group by clause. So you're still here in the group by clause, and here you can define the grouping sets, and you can still have the year and the month there, along with another grouping of the year. And then you will get the exact same result as on the left-hand side. These two queries are equivalent, except that the right one is more easy to write and faster to run, because the database understands what you're doing, And you can do these subtotals and higher level totals in one go quite easily. So this is what grouping sets is about. There are of course a few more details, like if you want to build a group over everything, the total that covers everything, you can use the empty parenthesis, like here. And there's also some function to disambiguate the case of null, and for some special cases there are some ways to handle with them. And there are also shortcuts for roll up and cube. The roll up is written out of there. So if you want to make a group by A, B, C, A, B, A, and over everything, then you can just write roll up A, B, C, and it will automatically create these grouping sets for you. So there's even a shorter version, an even shorter version, to get this rolled up to the supertotal. So this was introduced with Postgres 9.5, and it's in the standard for that was introduced in 2003 with the 2003 release of the SQL standard. So in which databases can you use it yet? That's the crucial question. We already know Postgres since 9.5. But as you can see, that the commercial databases have it for quite some while, but the open source competitors, they have it halfway. They don't have real grouping sets, they have only the roll-up functionality. So you can only do this A, B, C, A, B, A, empty thing. You cannot do like A, B, and BC and other combinations. And it's not following the standard syntax. So it's only a pretty small part of it. Still a useful part, but a small part. And Postgres has full support for some years now. So who would have needed that feature in the past? Quite some. You see? You didn't use it, you didn't know about it, but you would have used it if you would have known it. And that's one of the problems I try to fix with these talks and also with this website modernsql.com. Another feature, also introduced with 9.5, and it's the strangest feature you will see today. You cannot believe something exists in the SQL standard. Absolutely unbelievable. Table sample. What's that? Who knows? Alvaro? There are quite few. So it's what it basically says. If you don't need an exact result, but just an approximate result, you can just base your query not on the full table, but only on a sample from the table to make it run faster. You will get an approximate result, not the exact figure, but it will be faster. And sometimes that's good enough. So there's a feature for it. This is how it looks. The table sample follows the table name. You can say like system 10, which means 10%. The sample should be based on 10% of the table. And if you say system, it's on pages, on blocks. But you can also, if you need a better quality, there's another algorithm, Bernoulli, and then you get better sampling, better quality, statistically more valuable, but it's slower again, but still faster than a full table scan. And on top of that, you can also say, I would like to have repeatable results. Then you just have to provide a seed by the user, and every time you run it, if you give it the same seed, you will get the same sample, if the data didn't change underneath, of course. So that's there, Postgres 9.5. Who is running Postgres 9.5 or more recent in production already? You can use that already. Go ahead. Who has a use case for that? Oh. Okay, then I would like to know your use cases. Is somebody brave enough to speak up? Maybe in Spanish?
It's a feature of a library that is a client of Postgres that we have. It's a client of Carto. Carto uses Postgres SQL inside. So one of the features of the library is that it allows you to work with the sample, not with the full data set, but with a part of it. And you're using, actually it has two options. Through the library you can access, you may need a sample of the simple table, the table, and then we use table sample, or we may need a sample from a complex query and then we are not using at the moment table sample. Because we have already a complex query and
Yeah.
we have to sample it. So in that case we're using...
So these are the type of query, is it mostly statistical queries, like reporting for graphs? Or?
No, it's just it's a visualization library.
Yeah, visualization.
Data sets that
Okay.
Postgres have.
Okay, thank you. So there are use cases like this, like a chart. If you want to have a chart on some long time development, I mean, it's good enough for that. Okay, so thank you. So can you use that yet in Postgres? Yes, in 9.5 you can, and in, I'm sorry, in no other relevant open source database. So who's using MySQL? I was. Famous words. I was. And there was a second one, brave enough to raise your hand. Wow.
Usually I tell you the story.
Yeah?
So when I was on my former job, I stayed 9 years in Germany, the Dutch version. We were fighting every day because there were people that were preparing MySQL, people like me were preparing PostgreSQL. We were calling them the monkeys.
Okay.
Why? Because MySQL for me is for monkeys. So the monkeys is
Yeah.
anything that they can
I won't repeat this for the recording.
So MySQL is something that people with no knowledge they can start to use from day zero. And Postgres we need more knowledge. Anyway, after some years we could eventually use Postgres. So that's why I said I want.
Yeah.
Hopefully not anymore.
Okay, hopefully not anymore. So if you're using MySQL, you are unlucky you cannot use that feature, but in Postgres you can. And as you see in the commercial databases also. But we will also see features today where Postgres is the only green one here. So table sample. I find it a pretty strange feature, to be honest. There are use cases definitely, but this is not the most common thing I'm using in my queries.
May I say
Yes.
use case? It's not for us, but I've seen it where table sample could be very, very useful. It's the scenarios where you're drawing things on maps.
Mhm.
Maybe you're actually doing something similar, where the human eye cannot spot a lot of tiny, minor details. So if you have huge amounts of data, you're gonna put 1,000 dots where a very, very small unit nobody's gonna realize. You can just put a few of those. So a loss of precision in the query will not matter there because the human eye cannot see.
Yeah.
That
So
low
I think it boils down to the same effect. So what you visualized, there are some limits what you can make a difference out, whether it is a chart, like I think a common example, or a map where you draw some dots of some events, for example. Yeah, everything where the human eye has to interpret, there is some limit, and that makes sense maybe to base your graphs on the sample. No question. Okay, so that was Postgres 9.5. Now is coming Postgres 10. Spot the mistake. Yeah, what about 9.6? What about 9.6? I don't know. I ran through the release notes, and I didn't see a single feature that is really related to the SQL standard. There are of course a lot of features, but none that is really related to the SQL standard. There were a few were improved, but there was nothing new to really worth mentioning here. So that doesn't mean 9.6 is a bad release. There are a lot of good stuff in there, especially the first parallel execution. I like 9.6 definitely a lot, but in this topic here, SQL standard, sorry, nothing. So we are skipping to 10, which is the most recent production release at the moment. For us, like 2 months or so, we hope. So, what was introduced with Postgres 10? A function called XML table. Who is using XML? Okay, who is using JSON? Ah, you see? The good news is, there is a very similar function like this for JSON. I will show you that later on. But now let's stick to XML table. That was introduced with the SQL standard 2006, so that's also quite a while ago. And I will show you an example. What is it about? It's about turning an XML document into a table, as the function name says, XML table. Okay? And by table I mean like the result of a query, not necessarily something you create with create table, just the result of a a query is also a table. It has a column, it has rows. So let's say we have this XML document stored in some table in column X of that table, and it's pretty easy, a small document, and I will start the query. So I query that table, and I use that function, which is basically very much like a table function. So it returns a table, and it takes some arguments. The first argument it takes is an XPath expression. Who knows XPath? Okay, oh, that's quite a lot. So if you know XML and XSLT and so on, it's one of the tools you have there. One of them is XPath. And with XPath you can write a selection to pick some elements of an XML document. And what you see here is /d/e, which means start at the root because of the slash at the root, then pick the element called d, which we have there, starts here, ends here, and then go in there, pick the element e, which starts here and ends here, and yeah, every one you find, and that could be more than a single one, like in this example, every one you find, you have to turn into one row. That's what this expression does. It selects the elements that should be turned into rows. And once you have selected one of these elements, you have, of course, to specify which column where the XML data is stored. That's with the passing clause. But then you can define the columns. Because we have already defined the rows, which we would like to see. Now we define the columns. So I say here, I would like to have a column with the name ID of the type integer, and use the XPath @ID to propagate the data with. And if you know XPath, @ID basically means the attribute ID, this here. So it means there will be an ID column which will be... So question, why did I take 42 as an example? The answer to life, the everything, the universe, yeah. Okay, so who knows what I'm talking about? Okay, that's depressingly little. So there's the Hitchhiker's Guide to the Universe, who knows that? Okay, so there, you read it. Everybody who is not raising their hand, instead of buying this book, buy the Hitchhiker's Guide to the Galaxy.
Buy both.
Oh, he's the sales guy. Buy both books. It's a really good book, and you will understand later on. So that's what this columns clause does. You again give it an XPath expression, and these XPath expressions are used to populate the columns. So there I have the ID and the C1 column. Yeah. And you can also say a for ordinality column. Who has ever seen something like for ordinality in PostgreSQL? Yeah? Where have you seen it?
I've usually looked for building virtual tables from Rise, which I need a unique ID.
Yeah?
For my rows. So
Unnest, yeah.
That came from Python.
Mm-hmm. So it's the very same concept. So in Unnest, you might already know it. Who knows Unnest? Quite a few. So Unnest also has this for ordinality, and it basically means it's like a primary key inside this document. So you get for the row numbering basically. So if you have multiple rows in this document, then you will get 1, 2, 3, 4, 5, and so on. So you have a way to establish uniqueness. Okay, and I mean that's it already. That's XML table. There are a few more odd ends, of course, but these are details. At the end, you can just select whatever you want, and this is the result you will get. Okay, there's a question. What about the performance of the XML table? I think in the release note they wrote something like orders of magnitude faster than the corresponding implementation with the old XML functionality of Postgres. So I think it's good. It's just basically implemented directly in libxml, more or less, so it uses libxml. I haven't done any benchmarking on my own, but the patches mentioned that there is some very positive benchmarking on them. Okay, so that's XML table. Who can understand use cases for that? Okay. Who can understand use cases? If this was not XML but JSON, could you then see a use case for that? Oh God, everybody loves JSON. Can you use it yet? Yes, you can use it with Postgres 10, but here you see there's already a little bit gap. No open source database, not the relevant ones, is offering that yet. And even the commercial ones, SQL Server, is not offering the standard XML solutions. They have some their homegrown solutions, which is ugly, to be polite. So you see, Postgres is among the open source databases definitely a leader here. And let's go to the next feature that was also introduced with Postgres 10. Identity columns. It's also a standard feature. Who knows identity columns? Who knows serial columns? It's about the same but more powerful. And that's one of the beautiful things in the standard. When there is a feature described in the standard, it's quite complete. They think about all the different cases you could have. They are not just thinking about the common case. They are also thinking about the corner cases. And that's the reason why you have some more flexibility with that. So that's the syntax. For a table definition, you can say generated by default as identity. You can also say always generated as identity. But if you have it by default, you can still overwrite it with, if you mention it in the insert, for example. And then you can also configure it a little bit. Like you can say the first number should be 10, and then you make increments of 10. Why do I use this 10 numbering? Any idea? Alvaro?
Sharding?
No, not sharding. No, that's not what I was thinking of. Maybe to introduce elements in between, exactly. And what I was actually thinking about it, just because this was the numbering I was using when I was programming BASIC on the C64. Who was programming BASIC on the C64? So here you are. These are your line numbers. To introduce new line numbers in between. It's of course just, I mean, I put it there so I can demo some of the things you can do with that. There's also a cycle clause. So you can also configure an upper bound, and when it reaches the upper bound, that it starts over again for whatever reason. Okay, well, you can configure it. If you want to read about this, there's a great blog post by Second Quadrant. And the main topic in this blog post is actually not the functionality you can declare there, but how it compares to the serial columns, because the serial columns are kind of emulated. And if you then dump the database and re-implement it, there is some information lost. And this is now taken care of with the identity columns. So can you use that yet in your database? Yes, you can if you're using the Postgres 10. But not the other databases. So there are two of the commercial databases, and here's one of the things that was introduced with SQL, with the SQL standard in 2003. So that's here. And you see when it was introduced by DB2, before that. So that basically means they implemented and then pitched it into the standard. That's not an uncommon thing to happen, but this is the reason why they have such a leap start there, why they could make it far earlier than everybody else. Okay. So these were the standard SQL features out of Postgres 10. Now let's look into the not so distant future. Postgres 11. There is beta 2 already available. It's the second beta already. It's a good one. Take it. But don't put it into production yet. But test it. And if you find anything, just report it. That helps everybody. And I would like to show you some of the features that will come most likely with Postgres 11, but there is no guarantee. If there is a big problem found, patches will get reverted and it will be out. But as of today, this is still committed. Okay? So you will see that pretty soon on your closest Postgres installation. Over. Who knows the over clause? Yeah, many of you. Because it's not new. It's there forever. It's since 8.4. I don't even remember the year. But I need to show you the over clause, and you need to understand that before I can show you the extensions Postgres 11 is bringing to the over clause. So please stay with me, follow me with this. I will explain the over clause first, and then what's new to the over clause. And again, there is a problem it solves. SQL 92 was a really great standard, because it was composable. You could combine queries like Lego bricks and make more powerful, more complex queries and better solutions. But there were also some gaps. And one of the gaps is that two distinct concepts, which are actually two distinct concepts, there's one concept and the other concept, they were merged into one feature, and this is wrong. It turned out you need to keep them separated. And this is what they fixed with the over clause. And the concept I'm talking about is combining rows that share some common values in some columns. So this is what you typically do by group by, or also by distinct. If you want to combine rows, merge rows that have same value in all columns. That's the one concept, merging rows with similar columns. And the other concept is using aggregate functions, like sum, min, max, and so on. And these concepts were combined in SQL 92, and that was wrong. I will show you in another way, in a matrix way. So we will have four squares there at the end. And there's a simple query, just selecting some data from some table. And on the y-axis, I will show you the one of these concepts, like, does this query merge rows, yes or no? This one doesn't merge any rows. You will get all the rows. Even if they are duplicates, you will get duplicates. But if you put in there a distinct, as soon as you have two rows that have the same value in both columns, one of them will be eliminated. Only one will remaining. So this is merging some rows. On the other axis, you have the question, does the query use aggregates or not? On the left one, on the top one, you see it doesn't do any aggregates. But if I put it here on the right one, there you see I'm using a group by now, which says group by C1, so that all the rows that have the same value in the C1 column will be combined into a single row, and on top of that you are now allowed to use an aggregate function. I took some here, okay? But here is the problem. If you want to use an aggregate function, you have to use the group by clause. If you want to do some aggregation, you have to merge rows. And this is how they tangled these two concepts. But we have found that we would like to use aggregate functions without merging rows as well. But the guys from SQL 92, they were really brilliant guys. Really brilliant guys. They were way ahead of their time. But they were highly influenced by scientific thinking. They were basically scientists. And they had an answer for that. You can still do it. It's no problem. You can still do aggregations without combining rows. It's simple. I will show you with pure SQL 92, which can even run in MySQL and in SQLite and everywhere. How does it work? So if you would like to have the raw data plus one more column that has some aggregates based on that raw data, just start by selecting the raw data. And then join the aggregated data. And then you have both. Now you can select the aggregated data there as well, and you have the raw data next to the aggregated data in one result. Isn't that awesome? That's the power of SQL. That's the power of composability. This is the real idea behind the relational model. Let's just put things together. I can see your amazement. This is what I can see in your faces. Amazement. No, it's it can be done. Of course it can be done. But is it useful? Yes, of course it's useful. But is it handy? Is it a good solution? Is it quick? Is it easy to understand? Will it perform well? No, no, no. Just because it can be done doesn't mean it's good enough for industrial usage. And at the time of SQL 92, the industrial usage of SQL was not that big as today. It started as a scientific project. And for science, this is an answer. Like, just put these things together. But if we want to run our business on that, in the scale we have today, we need something more efficient, something more powerful, something more easy on top of it. And this is what we have now with the over clause, with the so-called window functions. Nowadays, if you want to do the same query, you do it like this. If you want to select the raw data without doing any grouping, just select the raw data without any grouping. And if you want to have one more column based on an aggregate function, just do it. And instead of putting an aggregate function, instead of putting a group by clause at the end, put an over clause right after the aggregate function. And this is now a little bit more complex, so I will go through with you step after step. I will show you an example, and you will understand how this over clause works. I will show you more than one example to understand the full power of the over clause. So look at this table, and look at the query. The table is basically the result of this query. So I'm selecting two columns from some emp table, employees. there are employees working in some departments and they are earning some money, all the same for sake of demonstration. And what I would like to do now is I would like to have one extra column that gives me the total salary for each department. But I don't want to combine the rows. I still would like to have each employee listed individually. Okay, how to do that? First of all, the almighty comma. Because I'm starting a new column, so I'm putting a comma there. That's all I do. Then I'm saying, okay, I want to use an aggregate function, the sum function in particular. So just put it there. And instead of adding a group by clause at the end, I'm putting the over clause in there. And the most simple over clause you can think of is over, parenthesis, open, closed. And that means apply this aggregate over the entire result set. Do you remember grouping sets from a few minutes ago? Okay, half of the audience is sleeping. So grouping sets also had the syntax like the empty parenthesis, which means over everything. And this means also over everything. Give me the total over everything. And if you run this query like this over spans the entire result set you have so far, and the new column will therefore have 6,000, because there are 6 times 1,000. And on top of that, you can use this over clause to specify over which columns this aggregate shall be done. And one of the ways to specify that is to use the partition by clause, which segregates the table very much like group by does. Columns with the same value in the partition by column will be put in the same group, like I have color coded here. It's the same logic like with group by, except that it does only partition them, it does not combine them. And the result of this is now a different result in each row, because the number of rows that are hit by this partition by clause is different. And this is what the over clause basically is. It allows you to use aggregate functions and some other functions, which I will show you shortly, without group by clause, and inside the over clause you just specify over which row the aggregate shall be done. Okay? That's the one aspect of the over clause, over and partition by. But over is getting more complex, more powerful. There's also an order by clause. And now it might be a little bit confusing, because what I've shown you so far is that you can use aggregate functions, sum, min, max, average, count, 5 of them, without group by clause. You can also use the more aggregate functions, but those basic aggregate functions you can also use with them. And all of them are not sensitive to the order of the values. Like if you do a sum, 1 plus 2 is the same like 2 plus 1. If you do a count, 1 plus 1 is the same like 1 plus 1. So why do we have an order by clause in the over clause? And the crucial aspect here is that it is not for the purpose of the aggregate function. It's for the purpose of defining over which rows the aggregation shall be done. I will show you an example. It's related to banking. Imagine you have an account table where you have for some transactions, like 6 transactions here, and each of the transactions has some value, like plus 10 means I have deposit of 10, plus 20 means another deposit of 20, and minus 10 is a withdrawal, and so on. And what we would like to have is a balance S of each transaction, so a running total. So the first row would get a 10, the second row would 30, and then we have 20, and so on, and so on, and so on. This is what we would like to implement in SQL. And now the scientists stand up and say, lo and behold, SQL is composable. I'll show you. It's as easy as that. That's one of the many possible solutions. You can just use a so-called scalar subquery. So in the select list, where you define the columns, you can put another query. You just have to make sure it's giving you one single column and one single row, and then it's fine. And in this other query, you can just look and accumulate all the transactions, summarize the values for all the transactions that are before or equal to the current transaction. And it's done. It works. It doesn't?
Not in MySQL.
Oh, it works in MySQL too, I think.
Because in MySQL you cannot use in a subquery a table that you are using for the set.
I would be really surprised if this doesn't work, but...
No, it's a limitation for MySQL.
Which version? how many years ago?
3, 4 years ago.
3, okay.
I can assure you, I was using SQL, and you get this funny error. You cannot use in a sub query the same table you're using in your main query.
Okay.
It was a pretty nasty limitation from SQL.
Okay, so there is the statement that MySQL has the limitation that this doesn't work. I cannot confirm, but I will definitely try out. I can easily imagine that this was true in some old version, but I will test it. I have old versions back to 5.1. I can take the query and back test it quite easily. I will test it. I'm really curious. So, yeah, there are 2 people in the audience confirming this error. I will test it, I will find it, and I will comment on the meetup page for that.
It's a feature.
It's a feature, it's not an error. Yeah. Okay, so this is basically perfectly valid SQL 92, and databases that have SQL in their name but still reject it shouldn't be used. There are other solutions to that. You can also do that with a normal join and so on, and then a group by, okay? So that's different solutions to that. From the perspective of the standard, from the science, that's a valid solution. Of course, it's not the fastest one, and so on and so on. But there's now a new version. Because here we have, again, that problem which I have been mentioned before. On the one hand, I would like to keep the raw data without applying any group by, but on the other hand, I would still like to use an aggregate function. And this is the pattern you have to store. If you see the situation, then you have to think of the over clause. This is what the over clause is for, using aggregates without group by. And the reason I cannot implement this using over like I've shown you before is because of this less than or equal sign here, especially the less than. Because what I've shown you was the partition by clause, and the partition by segregates data with the same value. That's an equal sign. But here I'm segregating with a less than equal sign, so you cannot implement that with the partition by clause. And this is where the over clause kicks in inside the order by clause kicks in inside the over clause. So let's start again. Now comes the more modern implementation. If you want to use a sum, just use a sum. If you don't want to use the group by clause, use over instead. So this is how it starts. And then, just for the sake of arguing with the database, I'm just trying to explain to the database what I want. And just for this sake, I'm using the order by to say, come on, everything I'm now saying is according to this order. Order by transaction ID, for example. And once I have established an order, I can say, please aggregate over the rows between unbounded preceding, which is the very first row in my dataset, and current row. And this is what we call a framing clause. And you see, while the database is looking at the first row, this framing only covers the first row. But in the result for the second row, it will see, hey, unbounded preceding is still the very first row, but the current row is now the second one. So now it will do an aggregation across 2 rows. It will add up those values. And on the third one, same, and so on. And this is why you can use the order by clause inside over to specify an order for the sole purpose to use this relative addressing, relative to the current row. So if you want to have something before the current row or after the current row, you have first to establish an order. And this is what the order by clause is good for, inside the over clause. The bad thing is I forgot something. I've shown you transactions, but unfortunately I didn't mention the account column. So what I now did is basically I have mixed transactions from your account and from your account. So the deposits were from your and the withdrawals from you. So good for you. How to fix that? There's an account ID as well. And it's easy because it can still be combined with the partition by clause. So you just put in the partition by there, which completely isolates each of these sets from each other. And then also the between unbounded preceding means the first row of the partition, not of the entire result set. And then you get the running total for each partition as shown here. So you can combine these concepts. And what the over clause basically does, it is a way to explain over which rows the aggregate shall be done. So that's the one aspect of the order by clause. But once you have established an order, also other functions make sense, not only aggregate functions. And that's the reason, like row number. So that's finally a standard conformant way to number rows, like 1, 2, 3, 4, 5. Row number over order by. And there's also ranking, dense ranking, percentile ranking, cum distribution, and so on. So there are some functions you can use for good. So to summarize, what you need to remember, what your trigger in your brain, create trigger. If you want to use an aggregate function, and at the same time you don't want to use a group by clause, think of the over clause, window functions. This is your trigger, okay? Install this into your head. The use cases are like running totals, I've shown that to you, but also moving average is a common use case. Like you can say rows between 3 preceding and 3 following. So that's up to 7 rows. For the first row, it will be only the current row plus up to 3 rows following. But once you are into the data set, it's up to 7 rows. It's a moving average you can use if you use the average function there. Okay. Ranking, use case of its own, like the row number, rank, dense rank, also very powerful. So if you want to find the 3 most common things for each group, for each kind of partition, you can number the rows in a partitioned way, which means for each partition there will be 1 to 3, 1 to 3, 1 to 3. Each partition will have their own numbering. At the end, you can just filter for the number in the partition, which means you get the first 3 for each partition. Top n per group. Also a common use case for this over clause. Avoiding self-joins. Scientists love self-joins. I'm not a scientist. I'm a practicing engineer. I like easy and correct code that runs fast. Self-joins are the exact opposite because you need to access the same data twice. So whenever you're doing a self-join was perfectly valid in SQL 92, but starting with SQL 2003, self-joins are mostly a thing of the past. When you when you find a self-join, kill it. Really, kill it. And the over clause is one of the important ways to do it. And there are many, many more use cases. I think the over clause was possibly the greatest enhancement to SQL in the last decades, in the last 2 decades. This is my claim. So to summarize, over may follow any aggregate function you can use. It's valid for all the aggregate functions, including string egg and all the other functions you can think of. It defines over which rows the aggregate function shall be applied. You can use the empty over clause as shown. You can use the partition by, and you can use the order by between to make even these sliding windows, like unbounded preceding to current row. And can you use that now in SQL? For quite a while. So it was introduced with 8.4 in 2009, so that's 9 years ago. In case you didn't know it yet, you have missed it. Life without over clause is almost impossible for me nowadays. And besides making you aware that Postgres is advanced of MySQL like 8 years here, so even if you take MariaDB, which introduced it like 1.5 years ago, even if you take this benchmark, Postgres was still 8 years early. And this is what I mean by this talk, how Postgres stays in advance of its competitors. And the main competitors are, of course, the free databases. Of course, also the commercial ones, but the main ones are the free ones. So it was 8 years early there. And I cannot I cannot overstate the importance of this feature. And one way to demonstrate that is how other databases, or kind of databases, data systems, more modern things, which don't speak SQL, also use this concept of window functions. So there's Hive, Impala, Spark, NuoDB. Some of them can do SQL, others not. But they are also implementing this feature because people need it. If you didn't know it yet, please learn about it. You're doing yourself a favor. And now I'm coming to some functions that were introduced later to the standard. They are still related to the over clause, but they were introduced with a later standard, but they were introduced to Postgres at the same time. And I show you another example. It's the opposite of the running total, the banking example I did, like plus the running total, running total. So you have a query and the result it gives you. And I have for each line, I have a balance. And now I would like to know the difference to the previous line. So instead of having the transactions and wanting to know the balances, I have the balance and would like to know the transactions. Okay? So how can we do it? And there is one way I'm going to show you without the over clause, or actually it also uses the over clause, and also the with clause. Who knows the with clause? Okay, I will explain it then shortly to you. But I will show you one perfectly valid way to write such a query without the feature that I'm just showing you then afterwards. So the first thing I'm doing is I add another column which is just giving you the row number. And I'm using the row number function there, which I just mentioned before, over some order, and I call it rn, and there it is, okay? And then I put it into a with clause. And a with clause is nothing else than a statement scoped view. It's very much like a view. So a view you can create. You can say create view, blah, 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 semicolon, enter, and then it's created and everybody can access it. But the with clause is still kind of a view, but it's not persistently created in the schema. It's only valid for the SQL statement that follows afterwards. The select, basically, that follows afterwards. So you have immediately following a select, and it's still one statement. Okay? So what I'm doing in this thing, that the table by its name, I then call it number T, because the table is called T, and this is now the number T. This is the name that I assigned up there, and I'm giving it an alias for current row. That's what I'm doing. I'm just giving it an alias, so I wrote the alias also there, so you can see this is the result as of now. And now there comes my most beloved self-join. It's a left join to the same table again, numbered T, but I call it previous now. And you might get it, if I put now in the on clause a -1 or +1 in that case, then I can make sure that the results shift by one line. So I have the current row and the previous row next to each other in the result. So now I can use this 90 and this 50 to calculate the difference between them. And that's what I'm basically doing here. In the select clause, I take the current balance, subtract the via coalesce, just for the null case, the previous balance. And now I have basically calculated the difference to the previous row because I shifted them next to each other but pushed one down. Oh, it's a nice solution. It works. But there's a simpler solution, and that's the new solution now. Yeah, one question. Just go back, I'll try to. Yeah, I clicked through, sorry. Yeah. The balance here is a null, or a 0 actually. Actually, it should be a 0, it's wrong, because I'm doing coalesce here. So actually this one should show 0. So you found a bug in my slides. So now I believe you regarding MySQL. Okay, let me show the new version of this query. The basis is still there. You need the balance minus the previous balance. But accessing the previous balance is now easy because there's a lag function. And it's a window function. So you need the over clause for it. And inside the over clause you need the order by. And if you say order it according to this criteria and then give me the previous value of this expression, of this balance here. And just one row before. You could write 10 there if you have the 10, 20, 30 numbering. And in case there is no row before, because this is the very first row I'm looking at, then give me the default value of 0. So you can even avoid the coalesced in there to get the 0. And that's the same like the previous query. It's just a little bit easier and a little bit faster. And this is what SQL 2011 introduced. And besides the lag function, there is also the lead function. So you can look into the future. You can look into the next row. That's easy. Just lead. And you can look at the first value and the last value and the ends value. That's all there. There are some limitations. Okay, Postgres does not support all of that, but most of that. So like the ignores null, respect null is not yet supported. But other than that, it works. Use it, go ahead. It's there for quite some while, Postgres 8.4. So who is running 8.3 or less in production? Okay, really. It's again you. So everybody running anybody running a supported Postgres version can use that already. Go ahead, it's useful. There are use cases every day. You would have needed it like 2 days ago, I guess. Okay, so this is what Postgres can do for 9 years now. And now I'm going to show you what Postgres will be able to do in 2 months from now with Postgres 11, if Postgres 11 is released at that time, which we definitely hope for. So there's the groups option. That's the name of the feature. What it is about, what I've shown you so far was order by, then some criteria, and then I always said rows between unbounded preceding and unbound current row and things like that. But there was always rows. But that's not the full truth. Instead of rows, you can also use range. And that's also old. I will show you what it does. So once you have ordered something by X, and I've highlighted the current row there, if you say rows between one preceding and one following, like I have it on the slide there, then it covers one row before and one row afterwards. As easy as that. But when you say range between one preceding and one following, then it uses the value of this column to define the range. So if you say between one preceding, it means it subtracts the value 1 from the value of the current row. So it takes the value of the current row, 3, subtracts this value there, 1, that gives you 2, and it covers everything that is 2 or greater than 2, greater than equal to 2. And the same on the upper end. So it takes 3 plus 1, which is 4, so it covers also the 4 in there. So this is range. Range defines it by the value, by the difference in the value. You can also use that on time-based things, like you can say between interval 1 day preceding and interval 1 day following, if you have a timestamp column. No matter how many rows, the number of rows is irrelevant there. It's just about the values. Okay, so this is range. And what's new now is groups. And this was introduced with the SQL standard 2011, and it will come with Postgres 11 if we are happy. There's always this gotcha. What does it do? It basically counts distinct groups, where rows which have the same value are just counted as one. So if you say one group preceding, it's at least one row, but if it has the same value like down here, 3.5, 3.5, then it just counts for one group. So it's basically done counting based on distinct values. And that's the difference to the rows, how the rows grouping works. Okay? And this is what you will have in maybe 2 months from now in Postgres. Then you can also say groups. Can you use that yet? No, you cannot use. You have to wait like 2 months before Postgres 11 is released in production. Can you use this in any commercial database? No. In any open source database? No. So Postgres, as of today, it seems like Postgres will be the first database out of the major databases I'm listing there, which will offer you this functionality. This is how we stay ahead of the competitors. And there is more to come. Also with the very first implementation of the overclause, with the SQL standard 2003, they defined the so-called frame exclusion clause. And that was not implemented in Postgres yet, but now it will come. What is it about? So if you have the overclause, and you're defining some frame using the between, no matter which of the between, or if you have rows or range or whatever there, you can then also say exclude. And if you exclude no others, so that's new in Postgres 11, if you exclude no others, that's the default. Nothing is excluded. But you can also exclude the, if you have the sample here again, you can also exclude the current row, which means no matter how you define your window, your frame, the current row itself will be removed before you do anything, like sum, min, max, and so on. And you can remove the current group, which is all the rows with the same value of the current row. And then the strangest thing is you can remove ties. These are the group, but not the current row. So this is another way how you can tailor your frame clause to cover only those rows you are really interested in. No.
The ties is my value, but not the rest. But complete the same value.
Pardon?
So the ties, you didn't understand the last one.
The ties.
Yeah.
So you didn't understand the ties. So ties is basically group,
Yeah.
but the current row stays included. It's not removed.
Okay.
So it removes these two rows.
Uh-huh.
This is what ties does. So I used red here to mark the rows that will be excluded. So if you say exclude current row, this row will be excluded. If you say exclude group, all the rows with the same value as the current row will be excluded.
The opposite to current row.
It's the opposite to current row inside the group.
Inside the group, okay.
So again, Postgres is setting the pace here, and the other ones will need to keep up. So this is already committed. You can download Postgres 11 now, it's just a beta. You can try that right now. It will probably be released in like a few months. I don't want to say any numbers. And if you're unlucky, it's getting reverted, but I don't think that we will be unlucky.
Is there any release candidate?
No, it's called beta 2. I think there are 4 betas scheduled usually.
There is no policy for releasing a release candidate in Postgres.
That's the way they work. Okay, beyond Postgres 11. So I wrote Postgres 12 and later. We don't know. So there are some patches which are worked on right now regarding features from the SQL standard which are not yet committed, and therefore they won't be in 11. They might be committed for 12 or not. We don't know yet. But I still would like to show you them. Merge. What is merge about? Who has ever heard of merge? Yeah. Who knows upsert? So this is this insert on conflict to something else. There is a standard version for that, and it's called merge. Question? On conflict. Yeah. So there is again the problem. Let's think about this problem in a structured way. If you want to use some insert, update, or delete on one table based on data from another table, you have a problem. Because insert, update, and delete in SQL 92, they have only the possibility to refer to a single table. There's no easy way inside the insert, update, or delete syntax to access another table. There are workarounds, or actually they are not workarounds, they are just composability. So it can still be done like I have done it here. I'm inserting into one table called target, and if I would like to insert data that I take from another table, I have to use a select clause to do that. So I can say insert into something and use data from another table to insert there. But if I want to make sure that I don't have duplicates in there, then I would need to exclude them from the actual data I'm selecting there. Okay? So if you have, for example, a target table and a source table, and you need to frequently put over data from there to there, like in a cron job, then the SQL standards, this is the solution, basically. And it's composable. You see how beautifully composable. There's one insert statement and a select statement, composed another statement. Composability like Lego bricks, isn't it awesome? No, it's not. The delete statement has the same problem. The delete statement itself can only refer to one table, target table. If you want to access another table in the same statement, you have somewhere to have the select. You have to use a select clause to bring in another table into scope. And that's the problem of all of these statements. You always have to use a select statement to bring in another table into scope. And the same is true for update. And there you see the most ugly solutions. If people want to update one table on base of another one, I will upload the slides afterwards, don't worry. It's again the same thing. If you want to update some columns in one table based on data from another table, you need another select statement. That's what it always boils down to, because you need the select statement for the from clause, and in the from clause you can then bring in another table into context. So that's the pattern we have there. So we always need to nest a select statement to get another table into view. And now we have the merge statement. It was introduced with SQL in 2008. And this is how it reads. Merge into target. And then it has the using source. And we have right here in the merge statement, we have a second table in the scope. We can join them using a join condition, like on, very much like join. And then we can say, when matched. So if you found a matching table in the target and in the source, then either update or delete the target. You can say so. And you can say even add additional conditions, like when matched and status equals deleted, then do something. And when matched and status not equals deleted, do something different. And you can also say when not matched and condition, then insert. And all of these clauses can be combined in every way. And that's what the SQL standards answer is to upsert, basically. So we don't have it in Postgres yet. There is a patch. The patch was already committed and reverted. Bad luck. Maybe with the next release, maybe not. So if Postgres is bringing this in some foreseeable future, it will be the first open source database to have that. And finally, before Alvaro kicks me off the stage, yeah?
I have a question. Can you combine this merge with the table XML that is being forced?
Can you combine the merge with the XML table? Yes, because the source table can be a query in the merge. Okay.
For exporting data from one system to another when you're doing a migration, if you can combine a merge.
Yeah, you can use in the source table. You can have XML. Then you can transform it to a table basically in the subquery in the source table, and then you can update some outer table. I think that should work. Okay. So I need to hurry up. We can also talk afterwards. Okay? He's already taking out the knife. Standard JSON. So I told you about JSON, and JSON has a long story. JSON was introduced to the SQL standard with the 2016 release. But it was already added to Postgres in 2012. So it was added to Postgres before there was a standard. So obviously, what Postgres does is not what the standard took. So Postgres does have JSON functionality, but it's not the one described by the standard. There are some major differences. Like Postgres has JSON data types, the standard has none. The standard just uses a string to store this JSON object. So they have a different mantra. And when I say Postgres doesn't support the standard JSON functionality, it doesn't mean that Postgres doesn't do JSON. It has just different JSON functionality. And these matrices, which I have there for you, if I have the access there, it means it does not support the standard functionality yet. So these matrices you see there, and there's a red X every time for Postgres. Postgres, as of today, as of the 11 beta 2, does not support any of them, not of the standard functionality. You see some other databases support some of them, but it is a pretty recent feature. It was added with the 2016 standard, which was released in December 2016, so it's about 1.5 years old now. None of them is supported yet by Postgres. But there are patches. There are patches currently in version 16 as far as I've seen, and these are like 16 patches by coincidence. And if you apply them on the current master, then you will see a lot of check marks there. So they are working on this. There are still some odd ends. It's not yet done. It's not yet committed, of course. You can see that. But it's worked on for 2 years on, I think now, in the meanwhile. And it's kind of, it's continuously worked on. So I think it will be committed at some time, but I cannot tell you any version number. So you see, at the moment the patch is almost as good as the competitors. In some cases even better, currently already. And I think it's a very solid basis. It will come. It's just a question of time. So this was the last slide of my comparison. And I hope you can understand now how Postgres really stays ahead if you look at this groups option and with window functions. And I was recently in Ottawa talking to the Postgres developer, giving them some hints which features I think strategically they should put effort into. So I really hope Postgres continues to stay ahead. The elephant walking into the sunrise, you know, from the beginning. So this is what I think, and I think this is one of the strong points of Postgres, rich and modern SQL functionality. And this brings me to my website, Modern SQL, you see it here. There's also a Twitter handle. It's basically a website which has articles which will eventually be put into some book, but you can also already read the articles for free. You can subscribe to the free newsletter, you can follow the Twitter handle. On the other hand, you have used the index look, which is the web version of this book for free. Also the Spanish version is online for free. You find the stickers and the coasters there, next to the pizza, as I can see now. Yeah, this is what I'm doing. This is what I'm excited about, basically. And now my final question is, I'm from Vienna. Who has ever been to Vienna? Just a few of us. There was a PostgreSConf in Vienna already. I'm sorry you missed it. Or have you been at the Vienna Postgres conference? A lot, of course. So sorry, that was a great opportunity to visit Vienna. But there's another great opportunity to visit Vienna, because I'm giving a training in Vienna on September 17 to 21. That's a full week, 5 days, covering performance indexing, everything you have in this book and more about performance. A lot of the stuff I have teased here right now, like how you work with grouping sets and avoiding self-joins and all these things, and some basics as well, type safety, null, and the three-valued logic of SQL. So it's really, it ought to be an upgrade for people who have using SQL for many years, but want to really level their knowledge one level up to the modern level of SQL we have today. So if you're interested in that, just speak up to me or visit the website. I would love to welcome you in Vienna in September. Other than that, I'm done. If you have any questions, either now or afterwards with the pizza.
I think afterwards.
Afterwards, I'm running out of time. And do you want to close?
Yeah.
Somehow? Do you need a mic? Ah, here it is.
This works? All right. So, first of all, thank you very, very, very much. Please, let's give him a deserved applause. He's not going to run away, so let's make questions with the pizzas, right? But, you know, I take on challenges. So, Markus told me that there's 3 books here in Spanish. And he said, you know, I can do whatever I want with them to give them away. So first of all, I thought about auctioning them. I'm sure I can get more or less €1 million if I auction them today, because they're really, really, really valuable content. Because of, you know, he might ask me to split the revenue with him, and he cannot bill in Spain so far. This will be illegal. So I decided not to do that, right? So what we're going to do is, you know, like TV, we're going to make a contest. And the winners of the contest will get the books. So the contest goes like this. I'm going to pose 10 very, very simple questions about SQL. Or a bit, some of them may be about Postgres. The questions, this contest is called the Boolean contest. So even though SQL is 3-value logic, we're going to only take it's going to say everything, all the questions are not null, right? So either it's true or false. There's no other option. If you disagree with the statement, you might think it's otherwise. I'm sorry, you're wrong. So let me prepare for this.
Do you want to connect?
I'll do it with my computer. So does this work? Yeah, it's coming there. Right. So this is the Boolean contest. We were actually running out of time just because pizza is here, and I know that's the most important thing for you. So this is the Boolean contest. The winners are going to take the book. So this works like this. First of all, stand up, please. Yeah, I'm serious. Stand up. And move a little bit to the back, behind the chairs. Now. Sorry. All right. Oh, it's not there? Let me clone the screen again. Is that better? No. Okay. That looks better, right? Yeah. Okay. So, this is full screen. Full screen. No, not full screen. Presentation. Presentation. All right. All right. So, what we're going to do is, this side of the room is going to be true. This side of the room is going to be false. If you think the answer to the question is true, come here. If you think the answer to the question is false, come here. If you fail, you go to the back of the room. Sorry, you cannot participate anymore. There's 10 questions. So, I'll give around 30 seconds. Actually, I don't have a clock, a stopwatch. Yeah, okay. So 10 questions. There could be no winners. That would be very, very bad. There could be many winners, in which case, well, you can fight for the books. And hopefully you'll get the books. Questions are easy, maybe. But we'll start easy. So, 30 seconds per question. You can all read from there? Okay. All right. Whenever you're ready, we'll start with the first question. I promise. So, I remember, this is true, this is false. There's going to be 30 seconds. You can decide last second, actually. But don't stay in the middle. That means you're out also. All right? Ready? First question. MySQL is more advanced than Postgres. I see someone in the... okay. Time is 10, 9... Someone is in the middle. That's going to be your out. 6, 5, 4, 3, 2, 1. All right. The answer is true. No, false. All right. So I think everybody can continue. All right. Ready for the next one? I told you it wasn't very difficult, right? Next one. Select count of 42 equals 100 from generate series 1, 100. Four, 3, 2, 1. All right, and the answer is true. So, all this work, I'm sorry.
So I guess you were all thinking there's an off by 1 error in there, but unfortunately there is no off by 1 error in there.
All right, this makes it even more interesting. Now, the people who are out, I definitely welcome you to still play. Either you don't qualify anymore for the book, still play raising hands. If you raise the hand that it's going to be on this side, you're playing true. If you raise this other hand, you're playing false. All right? But the other one, just move around. All right, let's move to the next one. Postgres 9.2.3 is binary compatible with Postgres 9.2.4. You can still change your mind. 10, 9, 8, 7, 6. Oh, I'm actually very slow. 3, 2, 1. The answer is true. It's binary compatible. Minor versions are always binary compatible. All right. Let's move a step forward. Select nulls equals null is not null. Nine, 8, 7, 6, 5, 4, 3, 2, 1, 0. And the answer is surprisingly false. What means null? Null is undefined value. We don't know what it is. It doesn't mean that it doesn't exist. So if we take two things that we don't know what they are, we don't know whether they are equal or not. So we output null. So null equals null produces null. So of course that's not null. So we're left with 2 players here. All right. Okay, you already got the book, but you still need to play. Everybody actually still needs to play. All right. So okay, you both got the book. Everybody come back again to the game. Yeah. There's still 1 book. You can make it. This is the second round, all right? So, 5th question. Still play, even the ones who got the book. All right. At the show prompt, if you run the following command, the answer is true or false. Yeah, I know. This is like this movie contest where it's like who knows that, right? Make a wild guess. 5, 4, 3, 2, 1, 0. The answer is true. Julian Assange has been a committer to Postgres. Yes, he has contributed code to Postgres. Now I guess the connectivity at the Ecuador embassy in London might not be very good. Maybe. Oh, who knows? All right. Number 6. Select PG start backup of Meta PostgreSQL Spain does not block concurrent queries. True or false? Five, 4, 3, 2, 1, 0. The answer is true. Postgres backup mode actually doesn't prevent activity on the database. So it does not. All right. Still a good group. Let's play with number 7. With TAB as values false, false, select not A distinct from B from T. Seven. 5, 4, 3, 2, 1, 0. And the answer is false. So in this case, basically, we are creating with the with clause a table called T. It's going to have 2 columns. This is a row predicate it's called in English. It's like a row literal. Yeah.
Table value constructor is that.
Oh, thank you. So it's going to take false and false. So basically, in other words, A is false, B is false. So false is distinct to false, no, and no, true. Did I do it correctly now? Yeah. So, did I say it right? Okay. So 3 players left. All right. Window functions. You should have been listening to this talk. Window functions return 1 or more rows per group of rows. True or false? 10. All right, I think nobody's going to move, so yes, the answer is true. You're in the good place. Yeah, that's actually the beauty of those. You can aggregate and return more than one row. A simple group by will return only one row. All right, we're getting close to the winner. Number 9. This is also a Markus style question. An index scan isn't always better than a sequential scan. Nobody's moving? No? All right, because you're in the right place. That's also true. Sometimes a sec scan is better than an index scan. Indexes are not always the best way to perform a query. So, last one. pgdump all -g backups every database in the cluster. True or false? Staying on the same side? So, 5, 4, 3, 2, 1, 0. You're creating a big problem for me. The answer is false. It doesn't. -g just backs the global objects in the database, which is basically users. So it doesn't back up the databases. So there's no winner for the last book. What do we do? Huh? Yeah? Let me know. Go ahead.
It did discover the null, 0 versus null in my slides. They found the mistake.
Ah, okay.
He's suggesting himself.
All right. What can I say?
So I think it's fair.
It's your choice. All right. So, thank you very much. We've got 3 winners. Come here to pick up the books. And let's get some pizza and drinks and ask questions to Markus and everybody. And let's talk about Postgres. And Markus has some final words.
One final word. There's a secret which I didn't tell Alvaro beforehand. I have a 4th copy of the book with me. And I will hand it over to Alvaro, and with the instruction to hand it over to the next volunteer out of this community here local, who volunteers to speak up here for the community. Having speakers like me flying in and so is the one thing, but you also need to exchange experience inside your community. So please volunteer, think about topics, suggest them to Alvaro. He will organize the meeting and the venue and the date and everything, and he will have a book for you. Okay? And now it's time for pizza.
Thank you, Markus.
Sorry for being late. We met together in one of the Postgres conference many years ago. Yeah, but one of those. You've been saying so many places, so I don't blame you.
Okay. Awesome. Awesome. Yes. Yes. Of course. And I really wish this happened because we're doing all. It's very, very, very well. Pues, adelante. Claro.
Falté una respuesta de no sé, no me moví porque la última no me la sabía.
Casi.
La del over sí me la sabía de memoria, pero la otra no.
¿Qué?
Porque el over lo usé malamente en la competencia.
No, pero muy bien, muy bien. Bueno, si te animas a dar una charla el meetup que viene, te llevas una. Anímate, piénsatelo. Piénsatelo.
Hay una que se podría dar, de las pequeñas conferencias que des al principio, de justamente lo que no he explicado, de por qué.
Pues, por ejemplo, anímate.
Lo podría hacer.
Mateo.
Eso lo podría hacer porque no es relativamente difícil.
Pero mándale un correo, un mensaje por el meetup porque si no se me olvidará.
Te lo puedo preparar.
Enhorabuena.
Pero eso, que no se use.
Claro. has ganado. ¿Qué quieres que le haga?
No te conocía.
Hay que hacer un quiz o algo. Muy bien.
No conocía.
¿No? Sí. Me lo comentas. Vale, sin problema. Ah, no, correo por la web, sin problema.
La verdad. Me apunté un par de horitas, pero finalmente no pude venir.
¿Te ha gustado? También a ti, sí.
Aquí sí que se van en otras ocasiones, pero...
So what do you think is the...
Álvaro.
¿Usted lo dice? Puede ser. No.
Es que ya se mezcla un poco las charlas.
Es que hace poco se denunció una conferencia de consecuencias de Microsoft con la compatibilidad. Esa es como yo. La botona, chica. Sí, de un meetup. Y al principio iba a ser una conferencia por
Features are there that are already offered by other databases, but not recommended. And you can also find the site online. And there is especially one feature which is called
Y más que es un competidor de...
Ya está.
¿Qué era?
Bueno, yo le dije que tenía que haber dormido, pero da igual. Bueno, ya le he dicho el error que fue el texto de Jonas.
Hombre, tienes soporte de funciones de ventana y tal, pero lo queremos comprar.
Se puede crear una variable para una fecha 20.
Es lo que yo creo que es bastante camino y ya vamos a comprar la prensa.
even more powerful than even more powerful than
Muy bien. Sin problema.
Aquí las cosas se hacen bien.
¿Tienes un bolígrafo?
No. Precisamente para eso lo quería. Para tenerlo firmado. Si no lo tengo firmado no me hace.
One thing I'm not sure is I don't have access to the standard, for example, and I don't know what is in there. That's a problem because
me neither. I studied it for some years now, but still not done.
yeah.
Others study the Bible, I study the standard. Both fine for and it has more than 4,000 pages.
Yeah. And I think
Do you have a pen? Do you have a pen here?
Only ugly pens.
Over there is just a few of them, but they're big ones.
Even more ugly.
I think this is terrible.
As ugly as offset.
I think I have on my bag. It comes.
Stage 2.
He's asking you to sign the book.
Again.
Dat is de man.
So it's the third.
Dat is toen mijn bitte unterschreiben.
Yeah, kann wir gerne.
Ja, danke.
Now you have it for free. Even better.
Yes, but I don't deserve it. I don't deserve it because the other lady also found back in the presentation. So.
Hopefully she'll do a talk.
That's the idea.
Yeah. Yeah.
Again, for the third time, it's 18 years.
No, I was just telling Alvaro that maybe in... I was just telling Navarro that maybe we can just explain...
No, I was going to ask you another question.
¿Quieres hacer otra pregunta?
Have you ever
Marcus,
found in
this
the
is the
standard-
first one that asked me to also sign as a reviewer of the Spanish version.
Of course.
So my pleasure to sign with you.
Please, go ahead.
Ahí tienes.
Guys, you're crazy. You don't know what you're doing. In a few years, I will be millionaire. I will put in eBay. Thank you so much, guys.
For free.
I was thinking if you have ever found in the SQL standard something that may not make much sense or that
There are some questions.
yes.
By the way, what I would suggest is
Okay, let's
no,
go there, let's
don't
go there.
stop. Just go over there and keep talking with your pizza in the mouth.
Let's go there and we can start. Okay. Yes, there are questionable choices. And I think that there are also things that don't even make much sense. There are things that may not have even a use case at all. I think.
I mean, there are so many features that are not implemented by a single database.
Right?
By no database.
Yeah.
There's stuff in the
Exactly.
standard which no database
Yeah.
can do. So the question is, what is it in for?
Yeah.
There are a few things, but in general, there's some of this very hard for a long time